Hello, guys. Good evening to you all. Thank you for attending or coming to our session here. And today's session is to be taken by Anshul, CSC department, second year. He is a member of our Hack Club, and today he's going to teach you all about 3D animation in React, like creating 3D shapes and animating them through React. And he'll also be showing how to apply physics and make a basic game using the 3D animation in React. And it's going to be a wonderful and cool funful session today. So stay tuned and enjoy the session as well as learn along with Anshul. Thank you. And Anshul will take over from here. He'll just show you some basic things of React and basic animations. Like he'll give you a basic intro about React, and I'm handing over to Anshul now.
Hello guys, thank you for joining the session. So we'll be talking about how we can use 3D animations and 2D animation over browser-based application like React. So the base of it all is Webgl. Webgl is an OpenGL-based API which uses something called canvas tag to create
Anshul, sorry to
animation.
interrupt. Hello, Anshul. Sorry to interrupt you. Can we wait 5 more minutes? Actually, as the participants are, currently joining in, can we wait for 5 more minutes? I
Uh,
guess.
okay, sure.
Yeah, just maybe the 2, 3 more minutes.
Oh, okay, sure.
Meanwhile,
Till
you can
then,
casually tell us about everything, and can you share the GitHub that link also with us, the reference
yeah,
link for everyone's reference. Yeah, thanks. Carry on.
I will put it in the chat. So we can just look into the things we can create with Three.js or React Fiber. This is a advertisement portal for Renault Escape. So you can actually go inside the car. We can do a lot of stuff with Three.js. It's ample of possibility. There's something else. This we can select any car model, color of any our choice. This is very complex stuff. Like building this will take a lot of time, and this car and this all objects are not actually created with 3ds. They are basically created in Blender or Maya or any animation software and imported here. We'll be talking about all this. There's something called particles. This one is my favorite. So it's a mouse trail. All this thing renders over your GPU. So the better GPU you have, the better it will work. There are ways to make your code more efficient so it doesn't load much on GPU. But yeah, at the end, everything is based on GPU. Well, actually, you can go over to 3js.org and check out this featured websites. This one.
Anshul, I guess we can start the session now.
Okay. So I'll just close this. So let's start. Let's get started with this. So
Guys,
as
if you have
you
any question, then you can either text us or like you can raise your hand, then we will get back to you. Yeah,
And
Anshul, continue.
Okay.
you can enter
Okay.
your doubts in the chat session, and we will deliver that to the Anshul.
Okay. So can I start now?
Yeah, Anshul. Yeah.
Thank you. So, uh, so we are going to be discussing about 3D and 2D animation over browser, like creating it over HTML or React. How can we achieve this? So there's something called Webgl. Webgl stands for Web Graphics Library. It's an API, a JavaScript API, which renders all your 3D, 2D animation over GPU. So it's an OpenGL based library. So anyone of you ever tried animation, you might have heard of OpenGL. It's an open graphics library. It's also an API, but it's cross-platform and cross-application, and it works on any language. So it's also GPU based. So this is the base, but like coding in WebGL is very intimidating. You like the code is so complex. Even creating a box is so complex that you need to add a lot of attributes here, and it isn't the right thing to do. So a guy named Ricardo Cabello came up with the idea of Three.js. So what he did actually, he made an abstraction of WebGL. So just a trivia, Three.js here is the biggest JavaScript library to exist, and the ecosystem around Three.js is huge, mm, like really huge. People have been building websites over Three.js like a lot, and all this labels and big companies are hiring Three.js developers for advertisements. I remember a site of Gucci. Their product called Marmont. Yeah, Marmont or Gucci. Yeah. So this website is built over Three.js. This website is just for their advertisement of their series of Mammon project. So as you can see, the whole website is just a wall, and there are frames of object. As you scroll down, different frame appears, and if I click on a frame, it will show me the object. And as I click on the object, it will redirect to the main site where I can see the object, see the object and buy it. Okay, so similar to it, all the products are in the frame with this design. So this is going on with the Three.js ecosystem, and Three.js is so big that it has so many classes. More than 150 classes are there for each and every object. So why Three.js became so popular? Because in WebGL, even for creating a shape, you have to write much more code. But what Three.js did, Three.js just made it simpler. Like creating a box, you just need to write 4 lines of code, and you'll have a box with you. I mean, all this buffer geometry, we will talk about what is buffer geometry. So it creates a box, and it applies the material to it and merges it with a mesh and adds it to the scene. Simple as it is. In WebGL, it would be like some 7 to 8 lines of code. Also you specifying all the vertices. You have to do it manually in WebGL. So Three.js became more popular. Everyone started coding over it. But still, Three.js wasn't the perfect thing. You can't create components out of it. So if you want to create two boxes, you have to rewrite everything again. Similar for other things also, the code was still intimidating. It wasn't perfect at all. So a guy named Paul Henschel came up with the idea of React 3 Fiber. Let me just open. It's a reconciler for Three.js. Like the Paul Henschel was a front-end developer, German-based JavaScript developer. He was looking for a way to use Three.js inside React, and he wasn't able to find any proper reconciler for a renderer for the React. So at the end, he started building his own. Genius. So he made this whole React 3 Fiber library, and it made the coding in Three.js inside React so much simpler, and it was much more efficient, and it's faster than Three.js. And it doesn't loads your GPU on each render. And as you know, if you know about React, React has its own DOM manipulation, React DOM. So if we keep loading all this 3D stuff inside React's DOM, it won't be like the efficient way. It will cost you much more. Like these 3D shapes are heavy. Like the size of these objects, the data they are transferring is much more. So it won't be the efficient way. So what he did, he created different a React renderer. So this thing is actually a reconciler come renderer. So it works for both React and React Native, uh, and it's much more faster than Three.js. And there's no limitation. Whatever you can do in Three.js, you can do in React 3 Fiber. So if you guys want to see like an example of what we can do, just take an example. Okay, so here we can see a let it open. So it's actually quite complex code, but I will try to make it simpler. This object here, this girl, is actually an object created in Blender or any other software and imported as GLTB file. We're going to be discussing it in the second session, I guess. So but Three.js gives you like the freedom. Like, see, I'm moving my cursor and the head is moving. Three.js give you this freedom, like you can manipulate the 3D object within your code. So that's the power of Three.js. And there isn't a proper documentation of React 3 Fiber, because it's everything there is in React 3 Fiber is similar to Three.js. All the classes name, just writing style have changed. Now we are using JSX type syntax. If you want to know what JSX is, so it's as React states, it's just a funny tag. So and inside a HTML tag, you encapsulate like hello world h1 tag is there. So and you can pass this entire thing in element, a variable. You can pass a HTML tag inside a variable. That's what JSX is. And JSX made the whole React thing more like efficient, more faster. So why we are using React is because React has this components, state management is there, hooks are there. We're going to be discussing that what are those. So let's get started with the code part. So I've already created a canvas here. I've imported all the required files. As we use these files, we will be discussing what it is. So let's get started with the app. And if you have no idea how React operates, so there's something called a public folder which has your index.html file. So whatever you write in JavaScript finally reaches here, and it gets rendered. And when you build it, the static generation takes from here. So in SRC, we have main index.js file. Whatever component you're going to build is going to be imported here, and this file is going to go to index.html file. So we have app.js, our first component file. So yeah, let's start with the code here. So we have only one function called app. It has canvas mesh. Okay, so what canvas is? I guess let me just go back to. Okay, so even Webgl, if you want to use Webgl in your HTML file, so you need to add canvas tag. All the animation whichever taking place on the browser should be in the canvas tag. Then only it will transfer that information to your GPU. Okay, so just like this canvas here, React okay from JSX.
Yeah, maybe I'm not sure. Like I thought that was the next last thing that we told.
Okay, so my screen is visible now. My entire screen. You can see the
Yeah,
code and all.
Yeah, it's
everything is visible. You can go ahead.
My Wi-Fi restarted. I didn't even know. Sorry. Uh, so I guess we should discuss this whole thing. I'll just remove the lighting and all. Yeah, I will remove orbit control also. So sorry for the interruption. Mesh. Uh, I'm going to start from the beginning again. I'll be quick. So mesh is basically an object which take all your shapes information and passes to the renderer, where it renders. It doesn't render in the React render. It has separate React 3 fiber renderer, where it passes all this box information, and you get a box here. So I created a functional component with ES6 style syntax, okay, and I imported that function here as a JSX tag. So you can create a function and import it as a like you might have used HTML tags. It's similar to that. You can just create a function and import it as tag. So yeah, there's that. So and box buffer geometry and standard material. Okay, so first thing I will go back to basic material, then we can start again. Yeah, so in basic material you can have color. Okay, but you let me just put orbit control and we can discuss about it later. Yeah, so as you can see, you can't even see the edges of the cube. That's the problem with basic material. Basic material, without even lighting, you can show colors and all, but it is uniform. So there aren't much shaders and all. That's why we use standard material. So what standard materials need light to show the object's color. If there isn't light, darkness is there, same thing. So we will put some light here. Ambient light. Uh, sorry. Ambient light takes a property called intensity. On you get a darker shade of red because the intensity is half. If I increase the intensity, it will go back to that whole thing. So I will just keep it half because we're gonna be using the other lights too. So the thing about ambient light is ambient light isn't coming from any source. It's already there. In the daytime, if there is you aren't like in daytime, your house is there's light because of sun, but inside the house there are a lot of refraction going on of the light, so it isn't coming from any source, it's just there. Similar to that, ambient light is not coming from any source, it's just there. It's making the object visible, that's it. Then there's other light called point light. Point light is like a bulb. It has a source and you need to specify the source. So it takes similar, like it takes intensity. All the light, all kind of light takes intensity, and there's other thing called position. So it takes position. It takes an array of the coordinates. So I will. The thing about the position is I have a viewport here. I just created a very simple design in Figma to understand it better. Wait a minute. So the object we created, this is viewport. This entire thing is your viewport. The area which camera is making visible for us is your viewport. Here it is, yeah. And this object is the object you created. And this thing is the camera. It's right behind the origin. So front facing. You can change the camera position as well, but we'll talk about it later. But yeah, this and the light is coming. The main light, the way you're seeing it, is directly reflecting from the origin. You see any object when light reflects from it. Same principle here. So I'll just go back to documentation. And yeah, so point light is light emitted from a point. Okay, there's something called directional light. Directional light is like sunlight. The source of the light is at infinity, and so that's why the rays coming from that source are parallel. but it's coming from one direction only. And this the thing about directional light is it can cast shadows. Like you want to make your 3D objects more realistic, so you need shadows and all. So your directional light can cast shadow. So let's go back and give position to it. So the more you code, the more you know how position works. Because I can't really. It's come from the knowledge about position come from practice. I can't really be sure about whether this thing is. If I'm not wrong, the light source will be from here. Yeah, the light is coming from here, so you can actually see. Okay, so I will create something called strip light. Strip light is basically same thing. Just if you have ever gone into if you have ever been interested in photography, you might know what strip light is. A light coming from opposite direction. So one light source is from here, the other light source is from here. So light coming from opposite direction is called strip light. Why it's called strip light? Let me just show you. Okay. I will create a speaker just to, yeah. So light coming from two sources opposite to each other, and there's a dark strip here. That's why it's called strip light. It's actually just a concept of creating light. That's it. Let's revert back to box. Okay, and we can use some hooks to make it more like interactive. So first thing I'm gonna do is uh, create a use state hook. I will talk about it in a bit. Just a minute. Use state. So what I did here is I just declared a state. This is a variable, and this is its what I say, like a function that will change its value. So I just created a state, and I will declare the initialize it with false. It's just a boolean. Okay, so nothing to worry about. And now what I want to achieve from this is when I click on this object, it should expand. So the mesh here has a property called on click. I guess everyone knows about on click. So I'm not going to be going into on click here. It takes a function and set expand to. I need to like specify what it wants to achieve. So here's something called scale. Scale is a property by which you can like scale the object, like increase its size and all. So I'll be just using a ternary operator here. Okay, so expand. It will take two arrays. Okay, here I will go one. I will expand it a little bit. It should work. Yeah, it's working. So yeah, so I just like on click, I change its value to true. But what I want, like if I click it again, it should go back to its original size. So not a problem here. I will just not equal to expand. Yeah. So it's working fine. Oh, I just that's right. Yeah. Now it's a perfect cube, and we can do something else too, like change the color in state. Let's try that. And initialize it with false. Okay. Now I need to like create another function and so I will just go here and I will declare ternary operator here. Okay. Yeah, because hover is set to false, the color is gray now. But I want, like, if I hover over this object, it should change its color to purple. So how I can do that? There's a very easy way in React. On pointer over, similar to on click. Yeah, equal to, similar to on click, it will take a function, and I will set hover value to true. So it's purple, but the thing here is, if I once I hover over it, it will stay purple forever until I reload the system. So again, I can't. So there's something also called on pointer out. I should do it. Set false. Yes, that should work. Yeah. So I can click, and as I hover, the color of the object is changing. So similar to this, you can interact with this cube much more. What more we can do? Okay, let's try to animate the cube. So we are going to be using another reference variable. I will just call a variable mesh equal to use ref. So use ref is just a hook which tells this variable that it's a reference variable. So I can use ref here, and I will just type in mesh. So whatever I do with this mesh, wherever I use this property, it will reference back to this mesh. And how will I use that? Let me just, there's something called use frame. It takes in a function. Okay, so let me just talk about use frame first. Uh, use frame is a render loop. So you never use the use frame inside your main component, the component which you are exporting. Never use it here because it's a render loop. It sends the information 60 times per second to the renderer. Never put anything heavy here. First of all, like a lot of don't put a lot of animation here because it won't be more efficient, and maybe your app will crash. So and never put use frame inside the main app component because it will go into an infinite loop cycle and the app will stop working, nothing will render. So you can use it inside a component. So let's do something. We will call our variable, reference variable, and there's something called current. So we know it's using like the current mesh it's using, and there's something called rotation. Yeah, so now you can see the object is rotating. Maybe I should change this to purple as better shade, I believe. Yeah, so as you can see, over x-axis, this cube is rotating. I have orbital control gives you the right to change the axis direction. So what I'm just rotating it. So it's actually I'm rotating the whole axis. So here's the thing. So the cube is rotating over x-axis. We can do something more with it, like yeah. So now this thing is actually is a factor for speed, the 0.01 which I've given. If I increase it a bit, we'll see it will go much more faster. Okay, and if we increase it by a substantial amount, like 1, like headbanging. So I will just take it to. Uh, we can do more animation from it. I'll show you another example. So mesh dot current dot position dot x. We can move the position even a bit. It will. I'm not sure about this, but let's see. Yeah, so yeah, so the object, like I said, the use frame will keep updating the renderer each second. So what it does I'm continuously adding 0.01 to the position of that mesh, and it's over x-axis, so it starts moving. But we can do something else. Uh, use 3 has this thing called clock, and we can not giving. Let me type it, then I will talk what I'm actually doing. Okay, something is wrong with it. Yeah, I was just continuously adding it in the loop. Now it should work. Yeah, so use 3. Let me go back to the React Free Fiber documentation. And there's something called hooks, and there's use 3. So use 3 has a lot of objects. Use 3 is basically a class and a hook, and inside it there's a class, and it has a lot of objects like renderer, scene, camera, and one of them is clock. Clock keeps track of the time. So what I did here is I just mesh current position x, the x-axis position of that mesh. I just used a time, get elapsed time. So it just starts moving in a loop. That's what it is. Sine is the sine operator of maths. So it's similar to that sine you have studied, but it instead of moving through angle, it's based on time. So get elapsed time does it moves that object back and to and fro through x. We can do same for y. So if I just do this. Head back, yeah. So it does it for while. We can do something else too. Die HTML, yeah. So we can't write HTML here. But let's suppose you need to add something like a text, something to with animation and stuff. So what will you do? So there's something in Die, the helper library which we discussed, has something called HTML. So we just need to write and here we can use h1 tag. Yeah, so you can write anything here. Okay, yeah. So you can see you can actually animate the text also over the object. Uh, what? Yeah. So let me just wobble this. This in Die only. There's something called mesh wobble material, mesh distort material. So these are just pre-built effects that Die gives you. Mesh wobble material. Yeah, so as you can see, the object here is wobbling. We can increase its speed. This something called factor. Inside the your mesh wobble material, you will just put factor and 0.5. Yeah, it's wobbling slow. Default is always 1. Okay. So I mean, it looks good, I guess. I'm just gonna comment it out. I want text here. Yeah. Same with stored material. Let's go here. As you can see, it's very easier. You just need to change the tag and whole thing is changing. So this thing is the factor. So now I can see it's not actually a proper square. The whole shape is distorting. And we have used get elapsed time, so it's distorting and reverting back to square. See, the one side it's and then we get back to being a square, and then again it will revert back there. So that's the thing. I will just use mesh wobble material. It's much more simple. Now we can go back and we can create a plane. Like for shadows, we can't. Right now, it's like there's an empty space and there's only this one object, and it's going to and fro and wobbling. That's it. There's nothing. So you need a plane like the surface where you can stand like that sort of thing. So I'll just create a return. Actually, you don't even need to create a function. We could have just created a group. Just to explain how the components work, I'm just creating this function. And we need plain buffer geometry. So I will head back to the plain buffer geometry. So plane is just a rectangle. Okay, but it has a lot different properties like it can have different kinds of material like shiny or something, and it can receive shadows from light source. So what properties does plane take? Plane takes an argument. In React 3.5, a plane takes just 2 arguments. Here it's 3. So if I increase it to maximum 30, you can see there's the plane. You can actually segment the plane more. These are just segmentation. So similarly, there are height segmentation. So you are just dividing the plane into different parts. We don't need all these things. We'll just stick with basics here. So yeah, plane buffer geometry. We will attach it to the geometry. All buffer geometry objects or geometry objects, you need to attach them to the geometry. We will pass the argument. It will take an array. I will just give it maximum. Similarly, as in the box, you need to specify the material also. So we're going to be using mesh standard material at the beginning. Okay, just specify the color. Maybe right. Yeah, sorry. We all the objects should be in mesh. That's the error here. So I will just cut it out and paste it here. And I will call the plane. Let's go back to our app. Cool. So you can see plane. We have a plane. It's parallel to y-axis and it's going right through our box. So that's why I gave the color red so that we can actually see the plane. So what we need to do is we need to move our plane 90 degree so that it gets parallel to x-axis. So it will be xz plane. Yeah. So let's do that. So there's some in the mesh only. There's something called rotation. It's a property of the mesh. You can actually rotate the mesh by this property. It takes an array again. We need to specify by what angle we are rotating it on which axis. So here we want to rotate. Here we want to rotate the plane in x-axis, right? So we will, and the rotation should be at the minus 90 degree direction, like pushing the plane backwards. So I will just do that. There's something called math.py. Yeah. So math.py is nothing but 180. I divide it by 2, I get 90 degree negative rotation. And I will do this and let's see if it works. Yeah, we have our plane, but as you can see, it's still on the x-axis. So what we need to do is we need to push this plane downwards. So here only in the mesh, we have this property called position. Position also takes an array. We need to specify the coordinates. So negative on the y-axis, we need to push the plane on the negative side. So I'll just go and negative. I guess that should do. Yeah. So we have our box. The plane is there. I'm gonna comment this out. This elapsed time thing. We don't need animation here. The rotation, I can just do it. Yeah. I will just decrease the factor. Okay. You don't need this much of wobble. I will just make small. Sorry. Yeah, it's working. And I will remove the plain color. Why do you need a color? Yeah, so you can see the plane And now let's try adding shadow to it. Okay. Okay, so for shadow, there's we have to use directional light, because directional light only can cast shadow. It has a property called cast shadow. Then we need to specify this mesh that it should be that it should cast shadow, and we have to specify that this plane will be receiving the shadows. So in Three.js, it would be much more harder. You need to specify like plane should be a shadow material, then you need to specify the shaders and all. But here we can do it simply. So let's get into it. Like this cube will have a property called cast shadow. That's it. And this plane will have a property called receive shadows. And yeah, now the main thing, directional lights. Uh, as I told earlier, directional light is okay. Intensity, I need more intense. And if I want to cast shadow on this plane, so directional light should be right above this object. So I will position it. Yeah, as you can see, the upper side is bright, so light is coming. I will just change the color effect to have a basic color only. I don't need. I will just comment. Where was this color? Yeah, this out. So you can actually refer to this uh, code here, and you can see the comment. There will be commented parts. So I'm not removing any code. I'm just commenting it, so you can you have this. Okay, yeah. So this too. Fine. Now coming back to directional light. Directional light. I've placed the directional taboo, but directional light should cast shadow too. So I will just use cast shadow. But still, it isn't actually casting shadow because mesh standard material won't work here. We need to give it shadow material. And there are other things as well. Okay, wait. I'll just take up to mesh. Have to do. Yeah, we need to do something else too. Uh, there's something called shadow map. Like we need to map all this shadow uh, somewhere because it's not like real world that an object will have shadow. Shadow is completely different object. It doesn't have to be it isn't related to the object. So we are actually relating it to object. So I've already written it as out, so I don't have to write it again. Wait a minute. I will explain. Okay, so I'm mapping the shadow. I'll just increase the shadow map size to the maximum 1024 1024. Then I'm placing the camera far, camera left. All the shadow materials have different camera properties, so you have to like specify them. Then your canvas, yeah, it should have shadow map property. Yeah, so now I guess you can see a light shadow here. If I go back and do shadow material, increase opacity. Yeah, so now you can see there's shadow, but shadow is rough here. It's not like a real shadow. So there's something called soft shadow, which is provided by dye. It's very simple to use. You don't have to do anything. You just need to like declare its instance. That's all. I do this, the shadow will be softer. There's more you can do with this. You can, yeah, you can actually increase the intensity of the shadow. Like if you increase the more darker it will get. I guess this is not the right choice. Okay, yeah. So now the shadow is softer. Uh, we can make it look much more better if we do it 10, I guess. Now the shadow kind of look realistic. Uh, there's one thing we need to do with our canvas. We need to add color management. It's a property. It manages color throughout your canvas, so you get like a proper realistic color. And we need to specify the camera here too. So thing about camera is camera takes position. You need you're giving it a position and colon, then array. The writing style here is different, little bit different. So I will just specify a camera in front, I guess. Okay, and there's something called FOV. Yeah, it's like zooming in, zooming out. So if I give 40, yeah. So if I increase, sorry, it's coming up. This to 60. Okay, so it's just basically a zooming property, nothing else. You're just placing camera if like in front of the origin, more closer, further. That's it. So all this you can do. Uh, there's something. What? Yeah, let's discuss a little about use spring. So let's go. The guy who created React 3 Fiber and Dye is also the author of React Spring. React Spring is a Spring physics-based animation library. It's like what is Spring physics-based? Like you know how Spring works. Like if you stretch it out or if you compress it, it will try to get back to its original position. Same thing is with the Spring animation. So if I put any animation in the React Spring, what it will do, it will do the animation, revert back to its original. So we can actually use Spring to do the scale animation. This thing, if I click on it, it scales. This thing we can more readily or more efficiently do with use Spring. So let's let me show you how it's done. I'll just create a so yeah, here React Spring. Also React Spring is cross-platform. Like it works on any React platform, like React Native, React PDF, or React hardware. It works everywhere on 4 platforms. So you need to specify which version you're using. So React Spring /3 is for React Web, the thing we are coding in the website thing. Okay, so it has a hook called use Spring and A. So the thing about A is, I guess, if you have ever done animation in websites, you know there's something called animated. It is just that. So the Paul Henschel, the guy, got tired of writing animated over and over again. So what he did, he just shorted it out to A. So nothing fancy here. So I'll just show you how you can do it. So I guess you need to like pass in props and use string. Okay, we are using state, so it will take an object scale. Yeah, it already has an object called scale. So we do expand. We write out. We already have the ternary operator. Here it is. Yeah, yeah. So what we will do, we will just copy it up, paste it here, and on scale we will write props. Okay, and so yeah, I think yeah, that should do it. Something is wrong. Props dot scale. Okay. Okay, yeah. So the thing is that you need to make it animated mesh. It won't work. Use string won't work in a normal mesh. So if your mesh is animated, then only it will work. Yeah. So now if I click, yeah, it's okay. So remember one thing: whenever you're using React Spring, you need to make your the mesh you're using it in. You need to make it animated mesh. A dot mesh. A dot mesh. Then that's it. It will work. Uh, and it's casting shadow. We can wobble it. I guess it's this is enough about the physics thing. I told I will, but I'm going to discuss the physics thing in the next session because it's a little bit too much. If I go on, it will be more than half an hour. So sorry for the interruption due to this. So, but I will just show you what physics can do. The okay, I will set back to. I will just show you something cool. Use Canon as a physics library which we're going to use, and there's something called React 3 GUI. So whatever we did in the code, you can actually do it by building a controller. So you don't need to like do all this long codes. Yeah, it made more simpler. Like whatever we built, building in it 3 years would have been more than 90 or 100 lines, about 100 lines of code. But here, wait a minute, let me. Here it was about how much line it is? All the shaders and all, it is around 50 lines. And if we add shadow, it goes 100 lines. And if you want to add shadow in 3JS, it will be around another 100 lines. So it's like we reduce the work half in React 3 Fiber. The thing about this React GUI is you can just import the controllers here. Like it's another tag, controls provider, and you just import controls in controls provider. That's it. You can code all the shapes you want. You can toggle them, interact with them, add animation to them. It actually made this whole thing very simpler. Uh, but what we wanted to use Canon. Yeah. So use Canon as a physics library. So uh, like gravity, mass, and third law of motion, all those things. Like two shapes, if two shapes are colliding, it should bounce. But if we gonna go back here, if any shape is here, it will just like it will go through each other, like ghost. It will go through each other. So if we apply physics here and add mass to it, and there's something called restitution. I guess everyone knows about coefficient of restitution. So same thing, if we add those things, it will collide. And if we provide gravity, it will fall. And there's plane, so it will fall over the plane. So those things we can do with the use Canon. Whatever we did here, even Drive, I actually have documented everything, provided link of everything. How to install the React app, I have also written about it. Those animation which we used, I have mentioned it, how to use it, how to create reference variable, everything, all the kind of material. You can actually refer to Three.js documentation for material, like we did shadow material. So here it is, shadow material. Shadow material, yeah, we did opacity, decided its position. So same thing. We just used a tag. Here it is 1, 2, 3, 4, 5, 6, 7, 8 lines. In the code, it was just a tag. So React Fiber actually made it a lot simpler to use these things. So and yeah, you can head back and check out what more you could do. Like there's this car thing. You can actually go inside. Your first person perspective with interior. There's this whole gallery view. You can choose between colors, and there are a lot more things you can do with this. Uh, this is whole catalog. This is a featured catalog. You, if you create if you like have created this level of project, you can actually send them your project, and they will feature it here. So yeah, submit project. So it's actually, you can try it out. It's great. Uh, we'll go back to React Fiber. Okay. So whatever we learn, we can actually apply it in AR VR by React XR. So this organization is run by the same guy who created this PM and DRS organization is run by the same guy who created Reactive Fiber. Yes, he created all these things also. Like, it's a contribution. Lots of developer liked all this library, so they started contributing, and it became a whole what you say ecosystem around it. There are a lot like GLTF loaders. We are gonna be talking about GLTF loaders in the next session. If you are interested, you can join webinar too. We can talk about GLTF loaders. We can do something like this. Oh, let it load. So if I click here, there's a game. So such thing you can do with reactive fiber. This was very basic. In next session, we'll be using physics. We will be importing 3D models, actual model, and we're gonna be using something called map control. So what map control gives you, you can like, you have played PUBG. It's a third person perspective. You can move your player around. So basically, map control is the same thing. Uh, there are other control as well, and yeah, you can actually controls, yeah, fly control, map control, device control. You can go through this documentation, see all what you can do. It's very well documented and very easy to use. If we go to this in SRC, the workshop documentation, you can go in app.js, and I have commented of using box. Like what we did here, we created a function called box. I did cube in the lives. So, and whatever we did, we can just simply do it by this much line. That's the power of die. Okay, the helping library. So it will just create box. We added props, attach material, factor, speed, everything, mesh all material. So it's much more simpler to use. You can, and it won't change your code much. You can check it out and everything. So this was all. I think I can end the session now. Anurag.
Thank you, Anshul. Thank you for your session. And does anybody have any doubt regarding Anshul's session? Any doubt? You can ask him. You can put up in the chat session.
Good. Thank you. Okay, guys, if the code was intimidating, so you can go through the code again. It's actually, if you go try to code it again and again, it will be much more simpler, because if we do same thing in any other like Three.js or Webgl, it will be more than 200 lines of code. I can guarantee you that. Yeah. So yeah, at first even the React code looks intimidating a little bit, but it's much more easier. If you're interested in this, like advertisement companies hire this 3D developers. If you're ever interested in this, you can like go through it. Thank you.
Yeah, thanks, Anshul. Uh, I guess if we don't have any question, we can wrap up the session. And yeah, definitely, this was really interesting, man. I guess we can implement something out of this in our Hack Club side as well. You know,
Yeah,
for
I was actually thinking about making a
yeah,
logo of Hack Club and then animating it over the website.
yeah. I guess that will be kind of cool for at least the club side.
Yeah.
Cool. I guess we'll be able to see a couple of more things from Three.js. And if you want to give a brief intro about the next workshop, what we're gonna do out over there, I guess that will be good.
Okay, sure. So I'm gonna head back here. So at starting, I showed you a demo of React 3 Fiber. What was there? So we in the next session, first thing we will study for the physics of what we discussed. Okay, but the main part of the next session is GLTF loaders. We're gonna be you can't actually create all these human figures, cars inside the React app with code. You can try, but it it will be like 10,000 lines of code. You have to like import many materials. So it will what thing will be easier if we create it over any like software like Blender and import it in our code and use it. So same thing happened here. This Stacy girl is actually a GLB file. It's a variation of GLTF, and this is a texture file of it. Okay, so this is I can't open GLB file here. So and Stacy's code is here. How the rotation, joint rotation, how the neck joint rotation will happen, and all that. Uh, and we are animating over this object, 3D object. We are importing it here in index.js. We are actually importing Stacy with the GLTF loader, and we are animating over it. So the next session will mainly focus on importing 3D objects inside your React website and animating them. Uh, it will be much more simpler than this. We are not going to do all these things. I will keep it brief and simple. If you can see, it's just 50 lines of code for this whole animation, and the Stacy is about 48 lines of code. So just imagine just 50 and 48 lines of code, and you get this. This is the power of React 3J, React 3 Fiber. That's that's it, I guess. This is what we're going to be doing next session.
Sounds really good, Anshul. Yeah, thanks for this session. I guess we can wrap up the session if we
Okay,
don't have any questions.
fine.
And
I'm paused. Sure.
yeah, and like this, like we'll create another GitHub folder over there, and we'll put all the references for that particular workshop. We'll share everything with you guys in 3 days. Yeah. Okay, guys. Thank you for joining. Yeah, you can stop sharing the. Yeah, I'll stop the recording.